I will be making this video to explain an example of iron-sulfur cluster and their electron spin calculation, and we will be doing that to explain if they are detectable in electron paramagnetic resonance or EPR. So here we take an example of these two and we will study each case. First we start here. So if we have two irons and two sulfurs, we will have this shape, two irons and two sulfurs. There are other cases, but here we will start. So we start by saying that we know the sulfur is charged -2, and since we have two sulfurs, the total charge of the sulfur will be -4. Now we want to find the couples of iron that exist and in which redox states they exist in. So in this cluster, as we said, sulfur is contributing to -2 for each, so -4. And now we find the possible redox status of the iron. Now we have to see in this kind of cluster, which is two irons and two sulfurs, what are the redox states that are possible in a cell or in nature, not in chemistry. In nature, there is only the possibility of these two. They can be either +1 as a total cluster, meaning this N right here can be either +1 or +2. Continuing, we have to see which possibilities are possible to get a total charge of +1 or a total charge of +2. Here we have +2. So let's continue seeing. So we either have the iron in the +3 or the iron +2. The total charge of this couple right here could be +5, and the total charge of this couple right here could be +6. So we have 3 +3 and 2 +3 here. And now, since the sulfur is given -4, we just calculate -4 plus X, which we want for the iron, which will give the +2, which is taken from right here. So we know we need +2 at the end, and we know the sulfur is giving -4, the two sulfurs are giving -4. So which one is iron giving? This leaves us with 6. So the iron cluster that can give 6 is this one that we have seen. So we know now our iron couple is Fe3 plus. Now we find the electron spin for the cluster. We know that iron has a 26 electrons total, but since it's in the 3 states, in the +3 state, we can put them in their orbitals like this, and we will end up in this case with 5 single electrons in the 3D. Each electron can be either +half or -half, depending on their arrow up or down. Here in Fe +2 we have 4 times, so we don't see the Fe +2. Let's actually put it right here. Right here, if you can see, if we add it right there, and Fe +2, we have 4 electrons, which will give us 4 times half. Each one is half, as we mentioned. We have 4 here, so 4/2 or 4 halves will be 2. Their electron spin will be 2. In the case that actually concerns us here, in this case right here, we find the electron spin. So we see that we have 5 electrons here, and we know each electron will give you half. So 5/2 will be our electron spin. And in this case of 2 Fe2s that we saw, that we are studying now, in this cluster, we have this couple that we saw, and the total spin of this cluster will be, the total spin will be the spin of the first pair minus the spin of the second, the spin of the first iron minus the spin of the second iron. Meaning we will have the spin of Fe3 here, half, 5/2, and the spin of the second one, 5/2, and the total spin is 0. In this case, when the total spin is 0, we call it an EPR silent. It cannot be detected in this case. Now I will move on by explaining the second part, which, since it is +1 and it has gained an electron, as you can see, the same cluster in a +1 state. Here we can see again the same situation. We have 2 sulfurs, -4 in total, 2 irons, since sulfur is giving -4. And we know at the end we have +1 in the total. So we have nothing, no other chance but having 5 plus for the iron as we calculated before. So in the 5 plus would be this case, Fe plus 3, Fe plus 2, which will give the total charge of 5. And if we come to the electron spin, now we have the case of Fe2 and we have the case of Fe3. We have 4 electrons here, right here, for the Fe plus 2, which will give us the electron spin of 2. 4 over 2 will give us 2. And the Fe3 will give us 5 over 2. Continuing, the total spin would be the first spin of the first iron, as we've seen before, and the second one here minus the second one. So if you calculate it right here, you would give 5 over 2 minus 2 will give you a half, which will be EPR active in this case. It's not 0. I want to give a second example quickly. This is a cluster of 4 irons, 4 sulfur, and the charge here is +2. And the second charge here, what we have after gaining electron will be +1 for the same cluster. So here we go again very quickly. The total charge of the cluster is +2, as we've seen. Again, we have here 4 sulfurs, each contributing with -2 charges, would give us -8 here. And to have a total charge of +2, how many do we need for the iron to actually get +2? We will need 10 charges, because the +10 -8 will give us +2. And continuing, the total charge needs to be 10. And to come to look actually at this cluster and its possibilities, we see that there are 3 possibilities that existence in nature. These are the only states possible in nature. And if we look at the irons one by one, so we need 10. Here we have +2, +4, +6. It will give us 9 at the end. So 2, 4, 6, 7, 8, 9. It is not what we want. We want 10. If we look at this on the other hand, 2 plus 2 is 4. And here's 3 plus 3 is 6. So 6 plus 4 is 10. And this is exactly what we need. If you see the others, here we will end up with 11. And here we will end up with 12, which is not the case that we want. Now, in this case that we have found it, we can see that they couple. We will have an Fe3 plus coupled with Fe2 plus, and the same again here. So we have 2 couples. Continuing to see the electron spin of these couples, exactly as we have seen before. We have 4 electrons for Fe2, we have 5 electrons for Fe3, and so the first couple, Fe3, Fe2, will give us 5 over 2 plus 2 will give us 4.5. And since the 2 couples are similar, we will have the same thing again. So the total spin of the first pair of iron couple minus the spin of the second one will be as the following. The spin of this pair minus the spin of this pair, which is in this case here is the same. We will be 4.5 or 5 over 2 plus 2. Minus 4.5 will be 0. So this is again an EPR silent. Continuing in the +1 status, the total charge is +1. So again, we will find our X to be +9 because the sulfur is -8 in total, and we will need +9 iron charges. Here in this case, we have this one that gives 9. And this one will give you the possibility of 2 couples. So the first couple that it can give is 2 plus 2. And the second couple will be this 3 plus this 2. Okay, so these are the two pairs that we have. We have a 2 and another 2, and we have a 3 and a 2. The possible couples, as we saw, and now we will calculate their, and we will find their electron spin. So first couple here, first couple spin is Fe3 plus 2. So we do the exact same steps. We have 4.5 here, and here in the second couple we have 2 times 2, like 2. It's a couple of Fe2 plus Fe2 plus. So both of them are like this. So both of them are 2. So 2 plus 2 is 4. Okay. So now the total spin, if we calculated the spin of the first pair of irons in this cluster, since we have pairs, we calculate the pair of irons, not just the single iron that we did here. I just want to compare it to this one that we did before. We did here the first spin of the iron itself, the molecule itself. Here we are calculating the spins of the couples. So where were we? We are here. So the spin of the first pair of irons, and we can see the spin of this pair minus the spin of the second pair. And if we put it, it will be 4.5 minus 4. It will give us half, which is EPR active. It can be detected. Well, I hope this helped. I don't want to make it too long, but as you can see, these are the oxidation status which are possible in biology, the ones marked in this green here. Possible in a cell. The same here and the same here. And you should take care of that. Good luck.